morning. We will continue on foundation engineering 6th session or 7th session. Basically, I was discussing about the steps in foundation engineering, and a few of the steps I have already discussed. Rest of the steps I will discuss briefly, and then slowly I will proceed to bearing capacity of shallow foundation. So, let me proceed to the next slide. These are the things I have discussed, perhaps understand project and site and develop design criteria. These two things I have discussed elaborately, and now we need to discuss that identify possible foundation alternatives. These are actually depending upon loading condition and the site condition. Sometimes we have several options like shallow foundation, deep foundation. Again, under shallow foundation we may have isolated footing, combined footing, strap footing, raft footing, like that, several of them, and sometime wall footing also will be there, strip footing or wall footing, and they will be assessed whether for a particular loading condition for the foundation they are suitable or not. Initial objective or target will be to manage or to adopt shallow foundation, and if you find that shallow foundation is not suitable, then obviously we have to look for other type of foundation. What is the other alternative? That is actually deep foundation. And deep foundation means what? That close to the ground surface up to certain depth, the soil condition may not be good, and that means if you apply the load, then there may be a significant amount of subsidence or even failure. So, because of that you have to transfer the foundation load or building load to a greater depth, and we do this by adopting deep foundation. And deep foundation, under that pile foundation is one of the deep foundation, then well foundation, pier foundation, all are there, and they are generally expensive. Also construction also takes longer time, even a lot of involvement will be there. So, until unless it is essential, we do not go for deep foundation. And another requirement of deep foundation, when the load is heavy, shallow foundation may not solve the problem. So, in that case also you have to adopt deep foundation. And now, this regarding this, let us whatever I have told, let me see some of the thing. So, how actually this, as I have mentioned, consider types of foundation, that means whatever there in my hand, different types I will select initially and assess benefits and potential problem with each. That means what? I may adopt, as I have told you that shallow foundation is economical, easy to construct. So, I may adopt first. Adopt means I will choose the shallow foundation first, and I will do different analysis, assess benefits and potential problems. Benefits means it will be cheaper, quicker, easy to construct, all those things are benefits. And what could be the problems? Suppose if I, for a particular area and for a particular loading, if you choose shallow foundation, you may find that the foundation will undergo huge amount of settlement, and that may result failure also. So, all those things to be finally assessed, and finally, you have to choose the best alternative. So, if you choose the shallow foundation, suppose for example, and in that case what are the different types of shallow foundations are there. So, I just shown here few of them, there can be many. So, this will be for example, isolated footing, or sometimes it is called spread footing. Why it is called spread footing? Just column is coming here, sorry, there is a column here, and then I will be spreading this load over the larger area by enlarging the base. And how I will enlarge this base, how I will select the size, as I have previously also mentioned that ultimately because of this, this foundation will impose some pressure on the soil, and how much pressure we can give, that every soil will have their limiting capacity. So, you have to select the size in such a way that the pressure given by the foundation should be less than the capacity of the particular soil, and this capacity actually depends on soil type and foundation type also, and that can be analyzed later on. For the time being, loosely I am saying that capacity of the soil. What capacity I have not do not want to speak now, because I will do it later on. So, this capacity of the, so I have to make the size in such a way. So, that means, if there is a capacity of the soil is suppose P and foundation load is Q, I will adopt area of foundation suppose A, and that gives you suppose another P 1. This is the because of the foundation. So, P 1 should be less than P, and of course, I have talked about I will talk about factor of safety. So, how much this and this, how much less or how much more it should be, and that has to be decided by a, that is another thing, that is factor of safety in foundation engineering, that we have to keep enough margin. So, if you keep the ratio is 1, that is factor of safety 1, the just verge of reaching the capacity, but if that is why to keep sufficient margin you have to go higher than 1. So, it can be 1.5 to 2.53, and I will show you later on that in foundation problem most of the time this margin will be 2.5 to 3 times, that means factor of safety to be used 2 to 3 times. So, that is the one, that means the base of the column we are enlarging to spreading over a larger area, because the concrete and other things strong material, but when it will go to the soil it has a very less capacity. So, to reduce the stress intensity on the soil, we are just enlarging the base, and that is why it will be called as spread footing, and also it is called isolated footing. Why? Because the individual column is connected by a enlarged base or foundation. So, that is why it is called also isolated footing, pad footing, spread footing. There are different names by which we can tell this footing type. And here actually main thing is that you have to give area in such a way that pressure given by the foundation should be less than the capacity. That is one aspect, and of course, as a geotechnical engineer later on you have to do other things like what should be the thickness, and then that should be what should be the reinforcement, all those things, that is the design aspect, that I will come later on. So, for the time being, so this is the example of spread footing. Next I will show you one more type of footing. This is actually another type of footing, that is called strip footing, sometimes called wall footing, sometimes it is called continuous spread footing. So, this was the thickness of the wall suppose, and again whatever intensity there below the column or this wall, if I put that one in the soil, again it will not be able to sustain, or it will exceed the capacity of the soil. So, because of that this base of the wall to be enlarged like this. So, it will be widened, and this direction can be any length, wall can be of any length. So, perpendicular to this, that this direction can be of any length. So, I can take a unit length, and I can take this is the width. So, that means ultimately here also over a unit length how much load is there, suppose Q 1 over a unit length, and area is B multiplied by 1, that gives you a pressure P 1 and that should be less than the P of the soil. So, this way, so that means here actually you have to find out what should be the width, that is the design thing you have to find out. So, that the pressure applied to the soil by the footing will be less than the capacity of the soil. So, this is the spread footing, the different kind of spread footing, that is sometimes called strip footing, that is like a strip continuous. Sometimes it is called wall footing, that is below the wall. Most of the time we use this type of footing, and sometimes it is called continuous footing. Sometimes instead of wall there can be of number of columns that can be connected by a strip, that also can be also called as a strip footing. So, so this way different names are given. Then this is actually another type of footing, that is actually a combined footing. You can see that two columns will have a common foundation, okay? And there are several areas where actually you need to do this. One important reason why we do, when actually you can stability will be increased, if 2 to 3 columns are put together, then stability will be increased, settlement may reduce, or chance of differential settlement also will be reduced. Another thing, while construction of the constructing this foundation, suppose this is a column location, this is another column location, this is another column location, this is a column location, this is another 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 column, like the building. Suppose there are several columns like this and they are located like this, and compared to the dimension of the column, your dimension of the footing will be quite large. As a result, means for construction time you have to first excavate equal to slightly more than the size of the footing, you have to excavate like this. Similarly, for this footing also you have to excavate. So, like that, that means if the area of footing required is such, when you excavate, then there you may find that will be overlapping. Okay? That means this footing is reaching to this footing, that may happen, or sometimes the excavation is so much that little strip of wall or soil is left. That means you are excavating almost entire area, keeping a small portion unexcavated sometimes is difficult and not economic. So, because of that, instead of keeping this small amount of soil here, if you can excavate totally and then two columns are given a common footing, sometimes it will be better many ways. So, we will discuss that also in the later on. So, these are the various reasons why we use combined footing. That means, combined footing means suppose this footing and this footing together I will put a common foundation, and the reasons are mainly if the excavation is too much for individual footing, then I can at it together I can excavate and then finally construct the single footing, and then that footing two columns can be started. So, these are the, this is also called combined footing, because of two or more footing when there will be having a common foundation, that is called combined footing. And again combine, when you will combined footing will design, there are again other aspect, like you have to first of all you have to find out area, and most of the time it can be rectangular, but if the unequal load or spacing is different or some other constraints are there, sometimes the area can be also of trapezoidal shape. So, that aspect also we will discuss later on. So, this is another type of isolated footing. And suppose those are there are many other, like mat foundation also another thing, that will be entire number of, suppose whatever number of 9 number of columns I have shown, instead of doing combined or isolated, if the entire base is first constructed like a mat, and then from that mat respective position the column is erected, that means all columns will have a common foundation, that is also called mat foundation. And mat foundation is also good shallow foundation, it is stable, settlement also will be less, but probably if it is not, but it will be expensive compared to other type of footing. So, because of that sometime we will not easily select at the beginning. So, those are all different types of shallow foundation, and those shallow foundation, when you find that because of some situation is not adaptable, then you have to go for deep foundation. And deep foundation means actually what? The foundation will be at a deeper depth, that is one thing. And when we consider this deep foundation, generally if the building is very tall, like this is a heavy building, this tall building means automatically you will have more load. Secondly, when tall building, there will be stability problem also. If you this is a tall building, and if you make a this much depth of foundation, then there may be stability issues. Okay. So, suppose if the foundation is stopped here for such a tall building, then there is a chance of toppling, that means stability problem. So, two things, that means one is when the building is very tall, then stability aspect, to consider stability, address the stability issue, we have to go for deep foundation, or because of the heavy load you need to go deep foundation, or when this soil surrounding this zone is weak, that means shallow foundation will not work. In that case, you have to go for deep foundation, and deep foundation actually finally how deep will go? Most of the time, if possible, you try to find out a stiff or hard stratum. Up to that you have to go, or if it is not available, sufficiently long pile can be made, and whatever friction force available along this, that will be enough to support the building load. So, I will discuss all details later on, that what is friction pile and all. So, as far as possible, that pile should penetrate up to a depth of where at least good soil is there, rock is there, that will be most preferred. If it is not, dense sand, if it is not there also it is possible, but as far as possible we try to reach to a better strata. And so, this is another foundation alternative, the deep foundation, and unless it is essential, we generally do not adopt this, and we adopt only for important structure, heavy structure, tall structure, like that. And next part is identify materials and get samples. So, next part was the select different alternatives and choose the best one, a suitable one, and next part actually conduct soil investigation and field testing. So, in fact, sometime the soil testing etc., can be done before foundation design, but sometime the reverse can be done. So, conduct soil investigation and field testing. So, in under that already I have discussed in soil in the quick review, that identify materials and get samples and data. That means, the site actually first you have to visit what the project site, and you have to guess initially what are the types of soil available there for just visual inspection, and then afterwards we may have to carry out a number of field tests, and then some of the things cannot be determined in the field. In that case, you have to collect sample and bring it to the laboratory for carry out some test and get the other parameters, like that. In combination of field and laboratory, you have to characterize the soil. Okay. So, characterize the site, that means finally, that means what type of soil present in this soil at a particular soil, what is the thickness, all those things to be determined. So, typically if there is a clay materials, then if clay type of soil is there, then we conduct typically CPT, then undisturbed samples from drilling and field vent shear test we carry out. So, that means, if the clay materials, clay type of soil if you see, then generally carry out CPT test, and we try to collect undisturbed sample. Okay. If I want to test in the laboratory, you need undisturbed sample. Undisturbed means what? That while getting sample, you should not, minimum disturbance will be created on the soil. Okay. There are some procedure, we will discuss that later on, and otherwise if it is a too soft soil, there is another field test method available, that is a vent shear test, that also I will discuss later on what it is, that can be carried out in the field. And if it is sand type of soil, then we can carry out CPT, simultaneously you can do SPT additionally, that you can do, and disturbed sample. So, sand actually the particles are not bonded properly. So, it is very difficult to collect undisturbed sample. So, because of that we just get the disturbed sample, generally to characterize like grain size and other properties to determine, we get disturbed sample in the laboratory. And then on that disturbed sample in a particular field condition, we can simulate and get the actual properties of the soil. So, these are actually two things, that means depending upon the types of soil, what type of field test can be adopted, that can be given guidance. Next is the determination of engineering properties from soil sample. That means, whatever we are doing the field, we get some data, and other than that, whatever sample you are collecting, from there also you need to find out the engineering properties of various other type of properties of the soil. So, engineering under that engineering index properties, this is that engineering index properties, this we have discussed under soil mechanics quite elaborately. Even in the review of soil mechanics, I have mentioned that water content, unit weight, these are the basic things to be first noted, and then if it is a soft soil or a fine grained soil contents, then you have to need to find out consistency limits, and if it is a granular soil, you need to do sieve analysis. Sometimes the soil is mixed type, then sieve analysis and consistency limit both to be done. And after doing that, what is the purpose of this? Again, using either grain size distribution or combination of or plasticity chart or combination of grain size and plasticity chart together, we can classify the soil. Okay, you can name the soil, and that is also how to do the classification step by step. Everything I have discussed also in the review, that first of all you have to see the soil. If the soil is organic type, how to identify organic soil? Color is black, there will be a smell, distinct smell, then treatment is different. And if it is not, if it is a inorganic type, again you have to see whether it is granular or it is fine grain. If it is granular, then straight go for a sieve analysis, and if it is a fine grain, then you have to do the plasticity analysis, and based on that you have to classify the soil, and two letter system you have to use. Suppose like SC, finally classification of classified the soil as this, it means what? It is actually clayey sand. Okay. So, like that, the finally you have to name the soil based on this investigation. Next part, these are actually index properties to qualitatively know the soil characteristics, but actual characteristics will be known by some advanced tests like strength test and consolidation test. Through the consolidation test, actually soil compressibility will be known, and strength test actually know the capacity of the soil, how much load it can take. And for strength test, actually we have several options. I have also mentioned, discussed elaborately in the soil mechanics class. Also in the review class, I have mentioned that we have direct shear test, we have triaxial test, we have UCC test, unconfined compression test, you have vane shear test, like the several tests are there. And again, if the triaxial test is the most suitable test, only mainly because why it is most suitable? Because we can simulate the different field condition. That means triaxial means all three direction will be stressed. That suppose if I consider a point inside the soil ground, then you will be that point will be subjected to pressure from all direction. So, similar thing can be simulated in the triaxial test, that you have to give a confining pressure and then you have to apply pressure from the top to reach failure of the sample, and based on that we can determine various strength parameter of the soil. And again this triaxial test, again there are several types. There can be unconsolidated undrained test, but very quickly you want to find out undrained strength of the soil, we can do that. But actually if you want to find out the drained test, the drained strength of the soil, then you need to carry out the other type of test, that means consolidated undrained or consolidated drain. So, those details I have discussed, so I will not able to again repeat in elaborately. So, that means there should be a strength test you have to carry out, and after carrying out strength test you have to find out the compressibility consolidation test, and through this consolidation test what we will get? The compressibility properties of the soil. That what is means actually? That means if I apply load, certain amount of load to the soil, then how much it will settle, that means how much compression will take place, and you know that every foundation will have some limiting settlement. So, until unless you know the compressibility property, then you will not be able to estimate what will be the amount of total settlement. So, this for that consolidation test to be conducted, and consolidation test means actually you have to pressure versus void ratio change to be obtained, and from there you can find out Cc, Mv, Av, there are many parameters, and based on which you can find out the consolidation property. And then in addition to that, you need to know that how long the soil will take to consolidate. For that actually another parameter, that is coefficient of consolidation. There are again various tests available. So, which we have discussed also in the soil mechanics. So, I will not do that here. And then characterize the site means actually what? That means ultimately after doing field test, then after knowing the geology of the site, knowing the laboratory test, finally you have to characterize the site. Geology, field testing, laboratory testing are consolidated using judgment and experience. That means using judgment and experience in soil mechanics or foundation engineering, judgment is very, very important. Why it is that if you collect a sample and carry out test, similar condition, almost everything is identical, but you test in 5 different places, you will never get same results because of many reasons, because soil will not be identical same, there may be some variation, then there are equipment, there is issue, then there will be operator issue, there are various reasons because of which you will get 5 different results if I test from 5 tests. So, ultimately you have to adopt a value which may not be out of any of them. So, that is actually the judgment, that means with experience the geotechnical engineer has to develop that judgment judging capacity, that after knowing all those things you have to finally characterize the site with certain values. Those values may not be exactly of any test. So, you have to in between some value to be taken, and so that your ultimate building which will be constructed will be safe and sound, serviceable. Then finally, you have to give a surface profile to be developed and identify estimate key soil parameter, that means what is the value of C, what is the value of phi, what is the value of Cc, what is the value of Cv, like that several other properties are there which has to be listed, and from there what should be the bearing capacity and all those things which can be estimated again from there. So, those to be identified. This is the typical soil profile. Actually, you can see that different depth how it is varying. So, you have to make a borehole, and over the borehole when sample is coming out from that, and what suppose I am advancing the borehole some 2 meter to 4 meter, and then you have got throughout same type of soil. Okay. So, when the as a fluid and soil mixed with water as a form of fluid is coming out, you can continuously monitor, and from there you will see that 2 to 4 meter is coming uniform. Certainly, when it crossed 4 meter, you may get a different types of fluid. Then from there actually that means you have to understand that there is a new strata. So, immediately you have to collect sample and you have to mark accordingly, and finally, you have to represent in the paper that profiling over depth, and if there is a borehole here, another borehole is here, and if you see similar type of things in same depth, that means layering is horizontal. If it is a some depth and if it is some lower depth, that means maybe there is a layering with sloping this direction. So, accordingly finally, you have to give the profile of the site with thickness of different soil layers, and then perform engineering analysis to evaluate alternatives. Again once again after test results and all, you have to once again reassess and see that whatever you have adopted, whether it is correct or wrong, and analyze what if scenario, that means if I do this what will happen, if I do this what will happen, or if I do this what is the benefit, if I do this what is the harmful effect. all those things if but scenarios to be examined, and finally, you have to make sure that whatever you have chosen, that is the right one. And perform sensitivity study, that means if I change this one, how it is effective, if I change this one, how it is effective this one, which parameter is more sensitive, all those things to be again identified at this level. And then foundation, then again develop recommendation and write report. They are actually finally, after doing all those things, whatever the steps we have examined, and based on that finally, you have to write report and give a recommendation that you should not do this, you should do this, or you have to do with this condition, satisfying this condition, or should some restriction, all those things in the form of report to be given. And you can see here that liability, what should be the liability, or if you adopt this, what should be the cost expected, whether it is economic or non-economic, or creativity or certainty of execution. That means, you have suggested something which is difficult to execute, that also you have to make sure by examining various parameters. And precedence, that means, that nearby areas what type of constructions are there, and based on that sometimes you can adopt easily. So, that also has to be then, or suppose in the similar area something is constructed, but it did not perform properly, that point also has to be considered for actually re-examining your whatever design you have done. So, these are the different aspects to be looked into. And finally, last step we have reached, actually this I will not be able to discuss under this, I may go to the next lecture, that finally monitor design, then construction and performance. The finally, after you construct actual recommend the design, and then it will be constructed. After construction also you have to monitor for some time, because what we are expecting, whether it is behaving as per that or not, that to be seen. So, that part in detail I will discuss in the next slide. So, with this I will close here. Thank you. Thank you.